Hello everyone, this is Hating Tian. This video we're learning 2.5 geometric sequences and the series. So if I have a pattern, for example, I have this example here. We have some terms, which is 2, 4, 8, 16, 32. What can you see? The first term times 2 can make a second term. Second term multiplied by 2 is 8. So times 2 is 16 times 2 is equal to 32. This kind of sequence we call the geometric sequence. Because the first term multiplied by something, I can get next term. Okay, let's see next example. If my a sub 1 is 1, a sub 2 is 1/2. You see, from a sub 1, 1, multiplied by a number 1/2. It is my a sub 2. And how about my 1/2? My second term times 1/2 is equal to 1/4. Is my a sub 3. How about a sub 3 multiplied by 1/2? Is 1/8 is a sub 4. So I found the pattern, which is, so if I'm looking for a sub 4, it is equal to the 1/2 times a sub 3. So the term is equal to the previous term multiplied by 1/2. So 1/2 is that special number. So we can clear this. So first term times 1/2. Second term times 1/2. Got to the third one. Multiplied by 1/2. Got to the fourth one. Multiplied by 1/2. That's the fifth one. So the ratio between successive term is always the same. Okay, the ratio R is equal to the term divided by its previous term. This is called a geometric sequence. Okay, if I have a sub 55, for example, it is equal to a sub 54 times the R, and isolate the R divided by a sub 54. So R is equal to a sub 55 over a sub 54, or any number. It doesn't have to be 55, 54. You can also just replace this number by 40, and the bottom must be one number less than 40. 39. You can also do a conclusion. On the top is n plus 1 over a sub n. Okay, let's see this example. Is this one a geometric sequence? It must satisfy that the first term multiplied by a number. Let's say it is r times r gets second one. Times r get next one. Also, I learned a formula here. R is equal to the term. Pick one of the term randomly. For example, I picked -4 divided by its previous term, -2. It is 2, positive 2. Yes, the R is 2. You can also prove. Use any term divided by its previous term. It is also 2. Okay, let's see. Recursive formula. A sub n is equal to R times a sub n minus 1. So the term is equal to the R times its previous term, where R is common ratio. Nth term formula. Here we have a formula to find a sub n. A sub n is equal to a sub 1 times r to the n minus 1's power. A sub 1 is the first term. N is a term number. So how did we find this? So we can clear this area to prove why this one is true. So if the a sub 1 and r is given, and we can find a sub 2. Okay, a sub 1 and r is given. What is a sub 2? A sub 2 equals the previous term, a sub 1 times r. And a sub 3 is equal to the previous term, a sub 2 times r. And we know a sub 2 can be replaced by this. So it is a sub 1 times r, this is a sub 2, multiplied by r. So we can make it to the power form, which is r to the squared. And a sub 4 is equal to a sub 3 times r, which is the form here, a sub 1 times r cubed, because I need to add, multiply by this r. And how about a sub 5? One more. A sub 5 is equal to a sub 4 times r, which is a sub 1 times r to the fourth. How about a sub n? A sub n, if I'm using the pattern here, we're going to have a sub 1 multiplied by r to the n minus 1. Because I see that if I have 5, then we have a sub 1 times r to the fourth power. So 1 plus 4 is equal to 5. And 1 plus 3 is equal to 4. 1 plus 2 is equal to 3. So a sub n is equal to a sub 1 multiplied by r to the n minus 1. So we found this formula. Okay, so how about a tricky question? If I have a 50, I say this one is equal to a sub 20 multiplied by r to the question mark power. What should I put here? We have a sub 20, not a sub 1. We did the conclusion here. We say the a sub n, my bad, a sub n is equal, the n is equal to 1 plus n minus 1. 5 is equal to 1 plus 4. And if I have a sub 50, 50 is equal to 20 plus, yes, 30. So here I must have 30. Then the sum of the 20 and 30 can make a 50. Okay, let's see the example, the question. List the first 5 terms of the geometric sequence with a common ratio of 0.2, and the first term is a sub 1 is 1000. So a sub 1 is 1000. What is the r common ratio? It is 0.2. So what is a sub 2? A sub 2 is equal to a sub 1 times r. So put r here. It is 1000 times 0.2. It is 200. And how about a sub 3? A sub 3 is equal to a sub 1 multiplied by r squared. You can also just say, we say a sub 2 is equal to, a sub 3 is equal to a sub 2 times r. You can also use the formula, which is a sub 1 times r squared. So if I'm using formula, I'm having 1000 times 0.2 squared. So a sub 3 is 40. And a sub 4 is equal to what? You can use either method. Okay, so it's a sub 1 times r to the third power is equal to 1000 times 0.2 cubed. It is 8. So how about a sub 5? I don't have a space. So a sub 5, make it short. A sub 5 is equal to a sub 1 times r to the fourth. It is 1.6. All right. Let's see. Next example. Is 5n squared plus 1 a geometric sequence? For the geometric sequence, they need to satisfy so a sub n is equal to a sub 1 multiplied by r to the n minus 1's power. Okay, let's see. This one gives us is the a sub n's value. I want to see if it can satisfy this equation. Okay, let me bring it back. Is true or false? So let me find what is a sub n. So bring the n equals 1 here. So replace the n with 1. I'm going to have 5 times 1 squared is equal, plus 1 is equal to 6. And how about the r here? I don't have a r. So the r is equal to a sub n plus 1 over a sub n. The term divided by its previous term. We can just find it from a sub 2 over a sub 1. So we need to find a sub 2. A sub 2 is equal to 5 times 2 squared plus 1. It is 5 times 4, 20 plus 1, 21. So the r is equal to 21 over 6. We can do some simplification. Divided by 3, top and bottom, 7 over 2. And how about a sub n? A sub n, bring it to the formula here. If it can satisfy the formula here, is equal to the a sub n here. Use different color. So if they are equal, that means it is true. So a sub n, use the highlighted formula. It is equal to a sub 1, which is 6, multiplied by r, 7 over 2 to the n minus 1's power. So let's compare these two. So this is a sub n. And in the braces, we also have the a sub n. Are they the same expression? No. So not the same. We say, no, it is not a geometric sequence. The geometric sequence must have the form of a sub 1, the a sub n is equal to a sub 1 times r to the n minus 1. Okay, let's see next example. Find the fifth term of geometric sequence. So the fifth term, a sub 5, is equal to a sub 1 times r to the 5 minus 1, which is 4. We can just make it simple. It is negative 2 times 4 to the 4th power. It is negative 2 times 4 to the 4th power is negative 5, 1, 2. Okay, next example. The 20th term of this, they gave us the sequence, and we need to find what is the a sub 1 and the r common ratio. First term multiply by what? Multiply by 2 can get the second term. Multiply by 2, multiply by 2. I can get my next term. Okay, you can, You can also find the r by using the a sub 2 over a sub 1 or any term divided by its previous one. So it is 10 over 5, 2. Okay, so the 20th term, a sub 20 is equal to a sub 1 times r to the 19th power. So let's put 19 here. It is 5 times 2 to the 19th power. We should use our calculator to find what is 2 to the 19th. Solution is 261,21440. Okay, let's see next example. Find the 10th term of square root of 2. 2 square root of 2, 4. First term, second term, third term, fourth term. So I will let you know this is a geometric sequences. What is the R? So R is equal to, pick any of them next to each other, the successive terms. I can use my second term, a sub 2 over a sub 1, and do the division. Where we rationalize this, we're going to have, so multiply by square root of 2, top and bottom, we have square root of 2. We can also prove it is true. So the first term, square root of 2 times square root of 2, it is 2. That's my second term. And then my second term, square root of, 2 times square root of 2 is my third term. Yes, it is. This is the geometric sequence. And we have the R, we have the a sub 1. What is the a sub 10? A sub 10 is equal to a sub 1 times r to the 9th power. It is square root of 2 times square root of 2 to the 9th. And we can combine these two together because this is square root of 2 squared. No square. First power times square root of 2 to the 9th. It is square root of 2 to the 10th power. It is square root of 2. Square root of 2 is 2 to the 1/2 power. Raised to the 10th power is 2 to the 5th power. What is 2 to the 5th? 2 to the 4th is 16. 2 to the 5th is 32. Okay, let's see number 5. Find the 8th term of the geometric sequence. If a sub 2 is 7, r is 1/3. So this is an interesting question. We did the conclusion that if we have the a sub n is equal to a sub c times r to the d's power. So c and d's, the sum of c and d is n. So c plus d is equal to n. So now if the first term is not given, but the second term is given, I can use this formula. A sub 8 is equal to a sub 2 multiplied by r to the 6th power. So how did I find the 6? Because I need to find a number. Add 2 is equal to 8. So that is 6. So the a sub 2 is 7. R is 1/3. Raise it to the 6th power. And then we can do the, we can use our calculator to find what is 1/3 to the 6th. If I want to keep the fraction form, we have 1 to the 6th power or 3 to the 6th power. I know that 1 to the 6th is just a 1. So it is 7/3 to the 6th power. What is the 3 to the 6th power? Let me see my cheat sheet. Is 729. All right, let's find number 6. Number 6. Find the 10th term of geometric sequence. If a sub 3 is equal to 3, and a sub 6 is equal to 1 over 81. And we are looking for a sub 10. I cannot write now. A sub 10. A sub 10 is equal to, if I'm using a sub 3, so a sub 10 is equal to a sub 3 times r to the 7th power. So I must have my r's value. How to find the r? Okay, by the given information, a sub 3, a sub 6. So we can list the relationship between a sub 6 and a sub 3. A sub 6 is equal to a sub 3 times r to the 3rd power, because 3 plus 3 is equal to 6. So a sub 6 is 1 over 81, and a sub 3 is 1/3, and r to the cubed. Can you solve for the r? Yes, we can solve for the r. So multiply by 3 both sides. So multiply by 3, multiply by 3. So 3 cancelled. We have 3 over 81. 3 over 81 is equal to r cubed. Do some cancellation. Top and bottom multiply by, divided by 3. 1 on the top. Bottom is 27. So r cubed is equal to 1 over 27. We can cube root of both sides. R cubed is equal to cube root of 1 over 27. We can cube root of the top. Oh, sorry, my bad. R. Cube root the top, cube root the bottom. 27. So r is equal to 1 over 3, because cube root of 27 is 3. I have the r. Can you find a sub 10? Yes. A sub 10 is equal to a sub 1 multiplied by 1/3, which is r. We can read this one later. So we say r to the, we don't have a sub 1. We can use a sub 3. And r to the 7th power. So a sub 10 is equal to 1/3 times, 1/3 to the 7th power, which is 1/3 to the 8th power. And it is 1 over 3 to the 8th power. It is 1 over 6,561. Okay, let's see next example. Write a rule for the nth term of the geometric sequence that has 2 given terms. So this question, find a rule of nth term. I'm looking for a sub n. What is a sub n? So for the a sub n, we have the rule if it is a geometric sequence is equal to a sub 1 times r to the n minus 1's power. I need to have the a sub 1 and the r's value. So we know a sub 1 is 1. And finding the r, I can find it from here. So we need to find this. So first find the r. A sub 3 is equal to a sub 1 times r squared. A sub 3 is 16, a sub 1 is 1, r squared. So we can divide it, divide it. So we can square root of both sides. And also r is positive. R is equal to square root of 16, which is 4, positive 4. Because I square root of the r squared, I'm going to have positive or negative. But this hint is r is positive, so r is 4. Next step, we bring the r to the a sub n. So a sub n is 1 times 4 to the n minus 1, which is 4 to the n minus 1, because a sub 1 is 1. Okay, we found the rule of the a sub n. Okay, number 8, write a rule for the nth term of the geometric sequence. We're looking for a sub n. that has two given term, a sub 3 and a sub 4. So it's very easy because r is equal to the term a sub 4 divided by its previous term a sub 3. So we just do the division between the 45 and 15. It is 3, so I found the r. A sub n is equal to a sub 3 multiplied by r to the n minus 3. So a sub n is equal to 15, yes, 15 times r to the n minus 3. Okay, r has been found. So r is 3. Okay. You can also represent this one by the a sub n is equal to a sub 4 times r to the n minus 4. It doesn't matter which number you choose. You can also find the a sub 1. So a sub n is equal to a sub 1 times r to the n minus 1. Finding the a sub n by using a sub 3 is equal to a sub 1 times r to the second power. Then we can isolate the a sub 1. But in your exam, if you gave me this expression, you got full credit. Nothing wrong. Oh, let me erase this. Let's see series. Some of the sequences is series. So series for the geometric sequence has a formula. So this is a formula. Let's memorize them. S sub n is equal to a sub 1 times parentheses 1 minus r to the nth power divided by 1 minus r. Okay, let's see the first example. Find the sum. Is this one a geometric sequence or geometric series? Yes, it is, because we say the sigma represents the sum. And on the right-hand side of the sigma, this is a sub n. A sub n. It has the same pattern like, let's wait. It has the same pattern like our, so this part is a sub n, is the a sub 1 times r to the n minus 1's pattern. Yes, a sub 1 is 4 and r is 3. I can tell this is the geometric sequence or geometric series. Okay, so how to find the S sub 6? Because this series is starting from n is equal to 1 to n equal to 6. So S sub 6 is equal to a sub 1 times the top is 1 minus r to the nth power, all divided by 1 minus r. So what is a sub 1? We just talk about the a sub 1. A sub 1, let's see, this is 4. And what is the r's value? It's 3. So we can plug in the a and r's value, which is 4 times 1 minus 3 to the 6th power. We should replace this n by 6. And the bottom is 1 minus 3. So we can use our calculator to find the solution is 1456. Okay, 1456. And some of you say, I forgot the formula here. I didn't realize this is the a sub n, the geometric sequence, the nth term. How should I do? So if I don't know this, but I still think this is a geometric sequence or geometric series, so I'm going to find the a sub 1 and the r. So a sub 1 is equal to, n is equal to 1 in this part, which is 4 times 3 to the 1 minus 1, which is 4 times 1. It is 4. And the second, I'm looking for a sub 2. A sub 2 is equal to 4 times 3 to 2 minus 1 is 4 times 3 is 12. And r is equal to a sub 2 over a sub 1, which is 3. So we can also find the a sub 1 and the r's value by listing the a sub 1, a sub 2. You can also just do the conclusion from all of this is a sub n is equal to a sub 1 times r to the n minus 1 pattern. N minus 1. Find the a is 4, r is 3. Okay, let's see. Erase this. Maybe I can leave this on the notes. So this is a sub n is a sub 1 times r to the n minus 1's power. Okay, next example. Find the sum of this. So we have the first term, second term, and the nth term. I don't know what is the last term here. So maybe we just say nth term. So a sub 1 is equal to 1/2. What is the r? Common ratio. We say r is equal to randomly pick 2 successive terms. I can pick a sub 2 over a sub 1. A sub 2 is 1/4 over 1/2. We can do the KCF. Keep the 1/4, multiply by 2. 1/2 is the r. So we have the a sub 1, we have r. But how to find the n? Because we have the formula for the s sub n is equal to a sub 1 times 1 minus r to the nth power, all divided by 1 minus r. So we have the a sub 1 and the r's value. But how about the n's value? We need to find what is the last term here. What is the nth term? Nth term is given, but what is the n? Okay, let's erase this and let's find the n. Okay. Let's say the last term is a sub n, which is my 1 over 2, 5, 6, is equal to a sub 1 multiplied by r to the n minus 1. So 1 over 2, 5, 6 is equal to a sub 1 is 1/2. Let's wait for this for saving the PDF. Okay, it is 1/2 times r. So r is also 1/2. We found it from the step here. It raise it to the n minus 1. We're looking for n minus 1. 1 over 2, 5, 6. My right hand side is 1/2 to the nth power because this is 1/2. Multiply by 1/2 to the n minus 1. It is 1/2 to the nth power. And then you can, so can you convert this 1 over 2, 56 to be 1/2 to what power? Sorry, I can use my calculator to find that 256 is equal to 2 to the 8th power. So I use my calculator. I tried that. I'm using this. 2 to the 8th is equal to 256. So the n is equal to 8. Yes. I proved that n is equal to 8. So a sub 8 is equal to 1/2, which is a sub 1 multiplied by 1 minus r to the 7th, all divided, why I should say 7, 8, all divided by 1 minus r. Okay, plug in the information. We're going to have 1/2 times 1 minus 1/2 to the 8, all divided by 1 minus 1/2. We can do the computation. The solution is equal to 6 So the solution is equal to 255. I'll divide by 256. I didn't do my computation, so let's do the verification here. 1/2 times 1 times on the top is 1 minus 1 over 256. The bottom is 1/2. And then flip this one cancelled. Yes, it's 255 over 256. No mistake. Okay, let's move on. Sum of an infinite series. Only possible if the R is less than the absolute value of R is less than 1. So R must be a very tiny number, like 1/2, like 0.5 or like 0.00004, or negative 0.007. Okay, not possible if R is greater than or equal to 0. So if R is a tiny number, so it's possible to find the sum. So we say the series is converges if the absolute value of R is less than 1. The series is diverges if the absolute value is greater than or equal to 1. We have the S here. Okay, that means we can find the sum if it converges. We cannot find the sum if it diverges. Okay, let's see the first sequence. So this one is geometric sequence. It has the first term, second term, and the terms. So what is R? R is equal to 6 over 18. Randomly pick two numbers. Second one divided by first one is equal to 1 over 3. So 1 over 3, absolute value of R is less than 1. So this one is converges. And for the converges sequences, geometric sequences, we have a formula to find the S sub infinity. That is equal to A sub 1 over 1 minus R. And for the next example, we have A sub 1 is 2, A sub 2 is 6. So what is R? I can pick randomly two numbers. I pick two easy numbers. So it's 6 over 2, which is 3. 3 is greater than 1 or greater than equal to 1. So you can also add the absolute value. So this is diverges. I cannot find the sum. If I'm looking for the sum of this sequence, that is infinity because I'm getting huge number in A sub n. So, or the A sub n is infinity. The sum of this sequence is infinity. And also for the R is a negative number, a huge negative number is greater, absolute value is greater than or equal to 1. So the sum is negative infinity. Okay, let's see the number 3. Find the sum if it's possible. So from this one, I can tell it seems like a geometric sequence. So this is the A sub n. Even here is K, but you know that the sigma is from a sigma of this geometric sequence. The index K is from 1 to infinity. So if the K is to the infinity, I can assume that part I circled is K minus 1 because infinity minus 1 is still infinity. So we can just say this is a geometric sequence or geometric series. So what is a K? So this part, we have the A sub n, and it's equal to A sub 1 times R to the n minus 1. So since n is infinity, minus 1 is just the infinity. We can ignore this part. So a sub 1 is 2, r is 3 over 4. So some of you say, I still don't like this method from the a sub 1, from the a sub n to find the a sub 1 r. You can also find the a sub 1 by plugging in k is equal to 1. 2 times 3 over 4 to the first power is 3. And a sub 2 is equal to 2 times 3 over 2 to the second power, which is 9 half. 9 over 2. And the r is equal to a sub 2 over a sub 1 is equal to 9 over 2 over 3 is equal to 3 half. Okay, we find the r, we have the a sub 1. Can you find the s sub infinity by using the formula a sub 1 over over 1 minus r? Yes, so put 3 on the top. 1 minus r is where is my problem? A sub 2. Okay, because the r here is 3 half and here is 3 over 4. I want to check where is my mistake. So a sub 2, I think there must be some problem on the a sub 2 is 2. It is 2 times 3 over 4. I copied the wrong question. So here is 4, it's not 2. My bad. And also the previous one has a problem. Here is also 4. My bad. So let's erase this part. So the a sub 1 is 2 times 3 over 4. It is 3 over 2. Over 2. And the a sub 2 is equal to 2 times 3 over 4 squared. So 16 divided by 2. The bottom is 8. Let me see if there's something wrong. Nothing wrong. Okay, let's do the division between a sub 2 and the a sub 1. So So on the top, we have 9 over 8. And the a sub 1 is 3 over 2. Let's do the KCF. So keep the 9 over 8, then multiply by 2 over 3. Do the cancellation. We have 4 left, we have 3 left, we have 1 left, we have 3 over 4. Yes, much better. Yes, it is. It matched our r here. You see 3 over 4. Okay, let's keep solving for the s sub infinity. 3, a sub 1 is not a 3. Made a mistake. So a sub 1 is 3 half. And then the 1 minus r is 1 minus 3 over 4. Okay, so it's 3 over 2, all divided by 1/4. Let's do the KCF. 3 half. Multiply by 4 over 1. It is, so cancelled, we have 2, 6. The sum is 6. Okay, find the sum if possible. So if it is possible, we must have our r, absolute value of r is less than 1. And this one, what is r? So we say all of this part represent the a sub n. So a sub n is equal to r times, why I'm saying r? A sub 1 times r to the n minus 1. And this one index we say k. It doesn't matter. So a sub 1 is 3, k is 3 half. So 3 half absolute value is greater than or equal to 1. So this one is divergence. So there is no possible to find the sum. So we say not possible to find the sum. Okay, let's see one application question. Initially, M puts $160 in the piggy bank on the first month. On each successive month, the amount she puts in is 0.8 of the previous month. What will be the amount she put in the piggy bank on the fifth month? How much saving will Anne save in piggy bank after a year? Okay, let's see. What is the initial money she put the first month in the piggy bank? So A sub 1 is equal to 160, and the second month A sub 2 she will put 0.8 of the R times the previous month 160, and A sub 3 you are using a 0.8 multiplied by A sub 2, okay, etc. So this is a geometric sequence. That means looking for what will be the amount she put in the piggy bank on the fifth month. Looking for the A sub 5 based on the geometric sequence is equal to A sub 1 times R to the fourth power. Okay, so A sub 5 is equal to 160 multiplied by 0.8. So R is 0.8 to the fourth. We can use our calculator to do the computation. So the fifth month she will put in, I think it's, 65, use a calculator, 65.36. Oh, sorry, 536. Okay, how about how much savings will Anne save in piggy bank after a year? A year equals 12 months. That means we're looking for S sub 12. So finding the S sub 12, we have the formula, which is A sub 1 multiplied by the parentheses 1 minus R to the 12th, all divided by 1 minus R. And A sub 1 is 160 multiplied by 1 minus 0.8 to the 12th, all divided by 1 minus 0.8. So we can plug in this in the calculator. We're going to have 745.0244. Okay, so that's the sum of a year she put in the piggy bank. Okay, let's see next example. Initially, a pendulum swings through an arc of 2 feet. What is the pendulum swings? So these are pendulum swings. So if, okay, let's wait for saving. Okay, we can draw an image. So here I have pendulum swing. So initial point is here, and it will go here, 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 here. And then I got this position, it will go back. So initially, this pendulum swings through an arc 2 feet. So that means the first time from this position to this position is 2 feet. On each consecutive swing, the length of arc is 0.9 of the previous arc. Oh, this is a geometric sequence. What is the length of the arc of a 10th swing? This 2 feet is A sub 1. So make it pretty, A sub 1. So 2 feet is A sub 1. And the 0.9 is the R, because each time The length is 0.9 of the previous arc. So previous arc multiplied by r is the next arc length. Okay, we can write down. We can look at the first example, the first question. What is the length of the arc of 10th swing? Is looking for the a sub 10. So a sub 10 is equal to a sub 1 times r to the 10 minus 1, which is 9. It is 2 times 0.9 to the 9th power. So it is 0.7748. So number B, after 15 swings, what total length will the pendulum have swung? Total length, that means S sub 15. S sub 15 is equal to A sub 1 multiplied by, let's erase this. On the top is 1 minus r to the 15, all divided by 1 minus r. Plug in the a sub 1, 2 feet. Inside we have 1 minus 0.9 to the 15th power, all divided by 1 minus 0.9. And then this one is equal to 15.8822 feet. So the first 5 swings, the pendulum will swing 15.885 feet. Number C, when it stops, what total length will the pendulum have swung? So we can assume that when it when it stops, the pendulum will swing for infinity times. So we can just find what is the S sub infinity. So if I want to find the S sub infinity, I want to verify my absolute value of R is greater than or less than 1. So absolute value of R is absolute value of 0.9. It is less than 1. So this is a convergence. If it is convergence, I can use the formula. So the formula is equal to a sub 1 divided by 1 minus r. And a sub 1 is equal to 2, divided by 1 minus 0.9. Is 2 over 0.1, it is 20. So 20 feet. So when it stops, the total length will the pendulum have swung is 20 feet. So that's the end of chapter 2. Okay, please be prepared for your exam.